No.
Yeah, I haven't plugged it in yet.
Alright, well, we are live, so.
Yep.
Share. Yes. Yeah, but right now, requires pre-scheduling for the other one, and only one person has the.
No, I'm good. I might need something after. Thanks.
Oh, yeah.
Maybe start at like 35 so we get more minutes. Yeah, I saw it. My computer sees something. I think what it's showing is there we go. Okay, cool. Oh yeah, it's kind of large. Yeah, with display settings. Yeah, it's like. Okay. Oh yeah, there's power. Oh, yeah. Oh, that's the hello. Hello. Unfortunately, it's not like the loudest mic. Yeah. It is on. All right. Okay. Can everyone hear me okay? All right. I think we'll go ahead and get started. So my name is Zac Swears. I'm a mobile developer for Uber out in San Francisco. Is it that boring already? Yeah, first a quick disclaimer. This is actually a talk that I've given before at JoyCon SF back in November. So this will be an updated version of that talk. Basically, we use a library that we built as a case study for this. So back up a second, also it's called API design as an art, not API development as an art. I think I accidentally said the wrong thing before, but yeah, it's going to be focused more on basically design of APIs and I guess a little bit about development of it too, but mostly kind of what kind of considerations you want to make into a library or app or anything that you're building. So without further ado, so at Uber, we have about 300 mobile engineers within the company. It's split between iOS and Android. It's about 50-50, and I'm on a team called Mobile Platform, where our job is basically to enable the rest of the engineers in the company to move fast and be able to build things without much trouble. It's not about specific like features or anything, but rather more like lower level kind of product infra is a common name you see for it at other companies. And we're trying to think about our libraries and tools that we build in the context of, not only does it work today, but is it going to continue to work well for people tomorrow, next week, next year, maybe. And thinking about this for hundreds of developers using it. And it's really important that we get this right, because if we don't, they just won't use it. Now, what do I mean by that? So the meta question in all this is like, what makes an API? And possibly more meta question for that is, what makes an API bad? And there's some really great examples in here, or in this space, that are best represented with metaphors. So this is a popular one used in design circles, where you have basically this notion of like, you build this nice walkway and it looks very nice and the designer is very happy with it, but then the user experience is clearly that they want to take the fastest way, and you end up with this sort of like, differing paths of what the user is wanting to do versus what the designer thought looked best. And developers are users too. If you're writing a library, your consumers or your users are the people that are using your library and their apps and their applications every day. And they're going to optimize for their own efficiency as a result of that. Now, this comes in different flavors. So this one is very obvious about like, this way looks nice, this way is what I want. There's other variations of this, such as avoiding ceremony, where you can, you can recognize if the user is going to go that way one way or the other, but they're going to pick the fastest way. Sometimes they can't even tell if the API does what they want, and so they just veer off in the direction that they are trying to go, and then they might eventually, at the end of this, realize that it did connect to where they're trying to go. But again, you can see a major what's the word I'm looking for? Differentiation disconnect of where the design was and where the user experience actually ends up being. And how you handle these cases are up to you, though, and that gets into another metaphor of there are wrong ways to handle this case when they come up. So you could acknowledge that it's a thing that people are doing and just try to pretend that it's not happening. Like, oh yeah, you're supposed to go this way. Please don't go behind the sign here. Or worse, acknowledging it and pleading with the customer anyway. My favorite one about this is that there's someone in the back bushes over there that has given up on both approaches. We made the joke that that's the path the QA engineer would take. And then the worst case is to basically just don't let them go that way and build a wall. And that's when people start doing ugly reflection hacks, or potentially worse things, or just not even use your library. So that's about making a bad API. What makes a good API? So who here, by show of hands, knows a good API when you see it?
Sometimes.
All right, so we have
small.
All right, we have like 1.5 hand wiggles to that. Now, who here knows a bad API when you see one? Okay. Exactly. So the answer is, it's really hard to say. It's a lot harder to recognize because a good API often reveals itself by how often you do or don't have to think about it. And one way to kind of capture this as a library developer is that you have to think of it like a tool. So a good tool is often limited in scope by design, and it just does one thing really well. So here you have a hammer. It's obvious what it's for. It has a really limited scope for use it to hit things into other things, and it does really well. And at the same time, it's a little bit flexible to how you use it. You've got grip, you have weight of the head, what material it's made out of, etc. But the purpose is still singular. And you have to assume that it's going to be used with a myriad number of other tools that you don't know about. A carpenter is as good as their tools is a popular quote, and those tools tend to be an orchestra of good individual tools that work together rather than one super tool like Python that does everything. If anyone here ever had like a parent or grandparent with a garage that just had like an entire like stockpile of different tools, like each single one has a very specific purpose. If you ask them, they'll talk your ear off about it. And there's a lot to be said for libraries that work well within an ecosystem rather than we're expecting the ecosystem to work for them. This keeps the library focused. And as a case study for this talk, we're going to dive into the iterations that we went through for a library that we wrote called Autodispose. Who here uses RxJava or is familiar with it? About half the room. Who here is familiar with the observer pattern? The same half? Basically, this library is for RxJava, but we try to keep it at a high level in the talk. But if you have any questions, feel free to just raise a hand and I can explain something. quick background on the library. It's a RxJava 2 utility for automatic stream disposal. So basically, if you have an RxJava stream, this is a library to help you dispose of it. It was originally built in a side project back in October of 2016 and mainlined into Uber in December later that year. And we open sourced it in March of last year. Now, here's a quick example, just in RxJava. So you have an observable. You're just emitting one event, and you're subscribing to that to get the event. It's fairly straightforward, vanilla RxJava. It's synchronous, etc. It's pretty simple. So now say we want to make this a network request whose result we're listening to. This is where things start to get tricky, especially in a mobile environment. So network I/O takes a long time. You shouldn't do this synchronously. And in Android, in fact, it won't even let you. It'll just kick you off the main thread and say, hey, you're not allowed to do networking on the main thread. So the way that we handle this in background, so spoiler for what I'm going to say next. The way we handle this in Android is that we push this off to the background and then observe the results on the main thread when it's like a very high-level callback system with this observer pattern. And now that we've got this threading sorted, now we have to consider another set of problems that Android gives us, which is that you are in a user space and the user might do something different while you're waiting, such as clicking the back button. So say we've got this in some detail activity and the user hits back, what happens? Anyway, you get a memory leak. The request is still in flight, but the user has now left the space entirely. And what's worse is that you could actually get a crash in here if the network request comes back and you try to touch buttons on the screen, then they're no longer there. You'll get a null pointer exception, or you'll get some sort of other weird undefined behavior. My favorite are apps that actually like back out of the current activity whenever it gets a negative response. And so you're in another activity already, and then it tries to call finish and quit, and then it says I couldn't quit, and it just explodes. There's like several banking apps that all have that same problem. It's a little bit strange. So we can prevent this by unsubscribing from, oh, that was supposed to be earlier. We can prevent this by unsubscribing from stream whenever we go out of scope of whatever activity or context that it's running in. So in RxJava, they have a notion of something called the disposable. Now, disposable is returned to you whenever you call subscribe, and you can take that and then just later call dispose on it, and that will do a best effort cancellation of the in-flight process or execution going on. So if your API request is using something like OKCDP in the networking stack, OKCDP will just close that that socket directly, and it cancels the in-flight request, and you can close off all those resources. Now, we wanted to handle this case automatically. Having to take this out every time and then call dispose at some point in the future manually can be pretty tedious, especially if you have a lot going on. And if you're familiar with this space, you'll know of other solutions like composite disposable or RX lifecycle. And this talk isn't really about which one of those you should use or how auto dispose compares. Although if you're interested, we have a section of that in the README. So what does auto dispose look like in this context? Well, for starters, it automatically handles the disposal, so we can chop that off. And to wire it up, we leverage RxJava's to operator, which is a little bit awkward to say, so here's how it looks. Which is basically just a sort of converter operator that lets you take the stream as one type and then return it as something completely different. There we go. Sorry, my speaker notes got garbled sometime between November and now. That's not a complete sentence. Okay, so yeah, and so for the scope of this talk, we're going to be talking about basically this API as to how it fits in between everything upstream and your subscribe call at the end. Now, auto dispose itself is just this class with a bunch of factory methods on it. Each factory takes in a scope, and we'll get to more about that later, and the type that you're binding to. So in this case, we have an observable. We would call that for observable. RxJava has other types like single or completable, and you'd have corresponding ones for that. Now, this to operator is a bit awkward. I always felt like it was a bit of a hole in RxJava's API because it just takes a function for each type, and so you can't actually like have one omni type or composite type that supports all these APIs. And so we have to do this sort of like weird extrapolation on the end just to specify which type you're going for. And we'll get more into that later. So there's three kinds of scopes initially in RX or in AutoDispose. The most basic version was a maybe. So maybe in RX Java is an emission that can, or is a stream that can emit either once or nothing and complete. In AutoDispose, what we said was basically when it emits, then that's the end of the scope. And if it completes, then your scope is unbound. This, in this context, is a little bit more abstract. It could originally be one of two interfaces. The first one was a scope provider, which is just a simple interface that can return a scope. It's a light abstraction and can be basically deferred to whatever parent context or wrapper you have, such as an activity. There's also a more complex abstraction called Lifecycle Scope Provider, which for anyone that used RX Lifecycle is very similar to that, where this hooks up basically very nicely to Android's lifecycles, where you can have corresponding events like create, destroy, start, stop, resume, pause, etc. And the idea was that you could implement this interface, and then based on these three bits of the API, AutoDispose could piece together a corresponding events notion for your scope. So implementation of either of these could be passed on, and under the hood, we would just resolve them back down to a maybe. Now, we probably rewrote this API from scratch like 6 or 7 times. Oddly, like half of those times we're on an airplane while landing, trying to do it before they made us put away our laptop. It was, that was a weird thing with this. So, not going to get really into the implementation details of how AutoDispose works under the hood, but focusing on the API. So going back to October, I've been doing sort of reactive lifecycle management for a while, and we knew that we wanted a very specific list of requirements for a solution for this. We wanted it to be disposal based. We wanted it to have a simple API. We wanted boundary checking. So if you tried to subscribe in a constructor or something before it's active, or if you tried to subscribe after it was destroyed, we wanted to throw an exception at you and say hey, you're way out of scope for this. You're trying to do new stuff when you're already done. And here are some sort of early prototypes for this. So the first one was to try to use a why is that? Okay. First idea was to try to use a Kotlin extension function, which was to basically tack on this dispose on extension to disposables, which in here looks very nice. You just call it in the chain like you would anything else. But then things get a bit weird once you start doing literally anything else. So say you actually implement your subscribe. Now you've got this subscribe here, and the dispose on is a little bit farther down. But from the mindset of someone writing this code, what they really care about is what you're doing in subscribe. And now you're asking them to tack on something to the end. But that's still not too bad if you've just got a one-liner. If you have a whole bunch going on, then it gets worse. And we've actually already forgotten to put on the dispose on at the end. But now, all right, this is clearly not ideal at this point, but we can actually even get weirder with this. So if you use the overloads for handling on next and on error, now you've got different functions in here. It's getting a lot harder to read. And yeah, we actually don't know when to necessarily check the life cycle. You could also have things like this where you say delay the subscription. And you could also have a case like this. So in RX Java, if you give it a full-blown observer, it doesn't return a disposable at all. It just returns void. So there's nothing to hook into there. And when I first gave this talk, my manager was also in the audience, and I mentioned that this is also not a great way to get Kotlin shoehorned into your code base. Yeah, back to square one. So we knew that we wanted something to decorate an observer rather than trying to hook into one every time at the end. So after a bunch of work, we had a sort of V1 API that looked like this. So it was called bound observers. You had to specify the generic. You had to specify the type. You had to take in the scope as a parameter. And you had this sort of buildery API. I called it a creator. I don't know why it's a builder. That you specify on next, and then you call create at the end. For brevity, I'm just going to focus on the subscribe here. So breaking this down, we have this bound observers class that just had static factories in it. It would dispense these creator objects through these factory methods. And again, we have to specify this generic. You have to go all the way across here. And then you would add on consumers for whatever different lifecycle events you had. So on next, on error, etc. And at the end, you built it and returned an observer that could dispose itself with the lifecycle you provided. Does this work? Yes, but at what cost? The first thing we'll notice is that this is really long. Screen real estate is actually really important, especially in the context of readability. Another is the ceremony. So my observer is a creator now, which oops, that was supposed to go over there. My observer is a creator now, and I have to always call create. Why is there an out animation? There we go. Okay. Sorry, it's been a while since I looked at these slides, and I got thrown off there. So, yeah, so we always have to call create. You end up with these weird, long, cascading builder effects. It's not terrible, but what if we want the case where we actually have a no arc subscribe, where we just subscribe to start the ignition, we don't actually care about listening for any of the results? If we want that to be automatically bound, we still have to do this every single time, which really sucks. Another annoyance that came up is that this generic here wouldn't autocomplete in the IDE. It's a little thing, but whenever it's gone and you start trying to write on next, all of a sudden the IDE just autocompletes everything to be object, which is really confusing because you don't actually have any indication before that as to where you're supposed to specify this generic. So if I have a stream of integers coming down here and it says, well, here's your object, I'm like, that's not helpful. So you have to put that generic there every time in order for this to actually show up to correctly. The last issue here, though, is the most serious. So what if we have a custom observer? Say, like, custom instance of an observer up here. This creator approach actually has no support for this. One solution is to create a base like bound observer class and make it everyone that wants to use that extend hours. But that's really inconvenient for a user. But it works sometimes until you hit observer types that you don't actually control. So say in RxJava you have a subject. It's an observer, observable implementation. In RxJava itself, we don't control that API. We can't just go magically make it extend our base class. So now we've hit a wall again. And how can we handle this one? Well, we can take an observer in as a delegate and make our disposal mechanics wrap around it. So this is one of those sort of classic examples of like composition over inheritance. Solves the problem kind of nicely. It works, but we still got other weird holes in our API that aren't that nice. So we have things like this, which is not really ideal because now my delegate might have an onNext implementation, but now I'm saying that I also have an onNext implementation. So even if we find a way to reconcile that under the hood, it's not remotely clear to the user of this API what it's doing. Another thing that this revealed that was totally legal was to do something like this. Only the last one would work. And it's not ideal. So, but now at this point, we do know that the core of this works. If we wrap around the delegate observer in here, we can basically just delegate to it and have our disposal mechanics sitting on top of that. So we know the core works. We just know the API needs some extra help. So that gives us a good baseline to work against. So we go back to the drawing board on this. The first thing we do is rename this auto dispose because that's a way better name. That's like half the battle in API design. So if you can pick a good name, you're good. The next bit is taking a look at that weird creator. So we changed it to actually be just this around API. You couldn't specify your own onNext. We got rid of the whole like builder creator stuff. And we had just overloads for different types of basically like Rx subscribe style APIs. So you could basically plug this in, you could wrap it around something, and it just worked. There's no builder involved. Each one is terminal, so you can't call this multiple times afterward. The empty case works in here as well, and it wraps up nicely into an interface that we can return as basically this clause from our auto-dispose factory class. This comes in handy later as well, because with this, with returning interfaces from factory methods, that gives you a lot of flexibility to hide whatever extensive state or implementation details you want under the hood without breaking downstream consumers. Yeah, so now we have some sort of parity with Rx's subscribe APIs, so this is more obvious. But around here is where we had sort of the V2 API. And this was about the point we brought it into the Uber code base as well. Next one, to make the scope more obvious. So this is the scope. There's a few parameters and types flying around here, but it isn't really obvious what this is for other than just being a parameter. So we extracted it to an intermediate clause to make it a bit more explicit. And this, yet again, required a bunch of plumbing changes under the hood, so we'll call this a V3. I mean, this also was nice because this is around the point that we made this about scopes in general and not necessarily life cycles and tying it to mobile setups. So next on the docket is that generic. Still a pain. So what do we want out of this? Like, first, we want auto-completion if possible. Like, this has to work well in the IDE for developers to actually enjoy using it. This is something that often goes missed in library development, where it's like, hey, this works and it's functional and it's guaranteed to be safe. But if it's really annoying to use, then people are going to type something else. Second, if possible, to have